Hi, and welcome back to Duende's web security video series. Today, we are talking about cross-site scripting or XSS. Before we dive in, make sure you subscribe to our channel so you'll know when a new video drops, sometimes even before I do. And if you find this video useful, please give it a like. According to legend, the term cross-site scripting was coined in a Microsoft conference room in late 1998, though the attack itself is even older. Here's how it typically works. A better name for cross-site scripting would actually be JavaScript injection. While there are variations that don't involve script code directly, most XSS attacks rely on an attacker being able to inject JavaScript into a web application. Most commonly, the attacker sends JavaScript as part of an HTTP request, for example in the query string. The web application takes the data and then outputs it directly into the page. And just like that, the attacker has script code running inside the application. All they need to do is convince someone else to click that link. This variant is known as reflected or non-persistent cross-site scripting. Even worse is when the application stores the attacker's input, for example in a database, and later displays it on a page. No link with malicious code is needed anymore. This is called stored or persistent cross-site scripting. There is also a third type, DOM-based cross-site scripting. DOM stands for Document Object Model. That's the browser API that lets JavaScript interact with all elements on the current page. In single-page application, where most logic runs in the browser, the server may not even be involved. This type is less common, but still extremely dangerous. We'll cover it in a future video. So what's the main mistake developers make that leads to XSS? They output user input as is. Whenever untrusted data is inserted into HTML, we must escape characters that have a special meaning in HTML. These include the opening and closing angle brackets, because they delimit elements such as script. Single and double quotes, they delimit attribute values. Failing to escape them allows attackers to inject extra attributes like on click. And the ampersand, which starts HTML entities. When using ASP.NET Core, the good news is that the standard way of outputting content using the add syntax, automatically HTML escapes everything. Let's have a look. I've updated the code provided by the Duende IdentityServer templates a little bit. So when looking at the claims of our current session, let's log in as Bob. We now have a filter, so we can filter for strings. For instance, we can look for SU, and then we get all of the claims and properties that contain SU. Here is the code that does the output. We do add and then model.filter, which outputs the filter values applied by the user. So what happens if an attacker tries to inject some code? Let's use something really simple. We filter for it, but no JavaScript code is run. We actually see the text. And why is it that way? Well, if you scroll to the appropriate position in the markup, we see that the HTML encoding has taken place. So for instance, the angle brackets were replaced by HTML entities. If you intentionally want to output unescaped content, you can use add html.raw Also, there is an HTML string class in .NET that also won't get escaped when output. But only do this with trusted input. Otherwise, things can go catastrophically wrong. Let's go back to the page. Let's try that attack again. This time, there's no escaping, and as a result, this time we have cross-site scripting. But what if you're not outputting data into HTML, but into JavaScript? The default escaping is not enough. A JavaScript string has its own set of special characters that are not covered by HTML escaping. Here is a simplified example. This time we are outputting the filter the user entered through JavaScript. It doesn't make sense here, but in general that's a typical pattern. Sometimes data from the user wants to be written or needs to be written into JavaScript. Usually that's not a good idea. We are HTML escaping here, but HTML is not enough. The application still seems to work as expected. Also, when we try to inject some JavaScript that doesn't work, I'm using something different now. I'm using an image with a URL that doesn't exist, so that image can't be loaded, which triggers the error event. And there we can inject JavaScript code. I hit filter, but escaping worked properly. Yet in a JavaScript string, another special character that is not an HTML special character and thus not automatically escaped is the backslash. For instance, using \u, we can use Unicode codes. The Unicode code for the opening angle bracket is 003C, and I can also replace the closing angle bracket with \u003E. Now I have angle brackets in my input, but using their Unicode representation. The HTML escaping doesn't care because that doesn't work in HTML that way, but it does in JavaScript. I have to be honest here, there is a security feature used in the IdentityServer templates. So hadn't I done additional changes in one file, that attack wouldn't have worked because that extra protection would have chimed in. In a future video, we'll talk more about that. Cross-site scripting is surprisingly easy to introduce, but also not too hard to defend against. ASP.NET Core, including Blazor, already provides good defaults that protect you from common mistakes. Just remember not to use HTML.raw unless it's absolutely necessary, and use it with caution. In the next video, we'll see how you can tighten things up even further. Stay tuned for more.